Okay, let's start our excursion into relational database systems and into SQL. I have already started a database system here. It's a database system Postgres, and I have prepared here an ASCII file with some commands in order to feed the database system. I have defined here, or I will define, a table, a relation in the database system. The table is called interest. It is very similar to the association that we have had in the UML model between the classes. There was this association interest. Here in the relational database system we have a relation. The relation has, a relation in general has attributes. This relation has two attributes, one attribute profile, another attribute subject, and I have taken the choice to call the attribute here profile ID and subject ID because the entries here, you see it already here below, the entries in this table will correspond to the IDs that we have in the UML object diagram. For the objects, the part of the object rectangle that the object ID, the part in the object rectangle that is in the topmost part before the colon. So you remember we had in the object diagram the objects Merkel, we had Putin, we had Trump, and we had May. And in one of the object diagrams we had these various subject objects, namely opera, hairstyle, shoes, and horses were the subjects that particular profile objects were interested in. This is represented here by the table interest with the attribute profile ID and subject ID, and I am associating the attribute text or string with both attributes. So these lines together, I will copy them from the textual file and paste them into the relational database systems. These lines taken together, they now have created a table called interest. And as we see here in the second part, we can access the tuples that are inside the relation. I copy this part. I paste this again here. So select star from interest. That's a very simple SQL query. SQL standing for standard query language. We have here a table with the two attributes profile ID and subject ID. And as we have not inserted any tuples here, no rows are available. Messages here, partly in German, null Zeilen, 0 rows available. Let's jump again into the text file. I have prepared here 8 statements that insert particular tuples into the relation interest. These 8 lines, these 8 tuples exactly correspond to the 8 links that we have had in the object diagram. Let's copy this here. Let's jump into the database and short feedback here on each of the insert that one tuple has been inserted. Let's go back to the query command here. I will press now the up arrow key here on the shell, and the last commands are available in a buffer, and here you see this command from the database system is still available. And you see a syntax error. What kind of syntax error? I have made a enter s here. Yeah, this looks much better here. There's a mistype in the file below, and I've corrected now the command. And as you see now, I have entered the command, and we now see the 8 rows that exactly correspond to the links, and we have 8 tuples now in the database system. I have prepared here some other queries, so let's copy these here as well and put them into the shell. I have now the star here in the first query was the indication that we wanted to have all attributes in the result. Now I have made a projection on only a particular attribute, namely I have made the projection on the subject ID attribute, and we see now as a result not a table with 2 columns but a table with 1 column. But in particular, you see here in the second column, of course, we have particular values that are repeated. So, for example, hairstyle or opera are repeated several times, and the select command, the collection that is returned in this plain select command, is a collection where duplicates are retained. And in order to have a result, where the duplicates are eliminated, I have added here the keyword distinct into the SQL query. The task of the distinct is to eliminate the duplicates, to show only distinct values in the result. And now you see here, for example, the duplicate entry of opera is now eliminated, and you have in the result only unique values. A further option that you have in SQL, we see it here in the third query, where you can order the result with the order by clause. This number 1 is referring to the select clause, and we want to see the result ordered by the first part of the select clause, by select element number 1, and we can copy this again and we can paste this into the shell, and now you see the result is ordered. We have here first the hairstyle, then horses, then opera and shoes, so this is the alphabetical order in the result collection. And one important point here to see is we started with this very simple SQL query, and we can build variations of this SQL query in order to eliminate the duplicates, and in order to order the results. We see a second or further queries here, and let's look what is going on in this query here. Again, I've copied it. In the query before, we have had we were starting from a table which was having duplicates, and we were projecting here on the subject ID in a very simple form with a very simple query. Now we are doing a little bit more of a complicated query. I have added here the aware clause, and I have expressed here that I want to see only the subject IDs for those tuples in the interest relation where the profile ID is equal to May or is equal to Merkel. And again, we see duplicates in the result. Both May and Merkel have interest in opera, they have interest in hairstyle, and they have interest in shoes. So each of the profile objects here have 3 interests, and in the result here we see now 6 rows, 6 tuples are in the result. Again, we could eliminate the duplicate by using the distinct option here. Let's do this here and paste this query into the shell of the database system. Yeah, and as you see here, I have added here the distinct keyword, and instead of 6 rows in the result, I have now 3 rows in the result. So, so far so good, except I have prepared 2 examples here for the study of relational database systems, and I have here used the relation interest. I have prepared here a second example. I have defined here a table called integers. The table has one attribute, and the attribute is simply called I. And I have fed here the table with particular tuples. It's a very simple table with just one column. So I have to mention only one column here for the tuples, and I'm inserting -2, 0, and +2, or only 2 inserting these tuples into the relational database system. So let's do this here. Let's copy this part. Let's paste it onto the shell. Yeah, you see the table has been created. The tuples have been inserted, and as before, we can now copy this query, insert it on the shell, and you now see, okay, I've inserted 3 different integers, and these 3 different integers are sitting inside the relation. Please note that in contrast to the first example, in the interest relation, we have had some duplicates there in the tuples already. We do not have any duplicates here inside the relation. So the relation has no duplicates. -2, 0, 2. It's a set of values which sit inside the relation. And now let us have a look at these queries I've prepared here. 4 different queries. Let's copy it, and again let's put them and paste them onto the shell. Let's massage the display here a little bit so that we see the result of all 4 different queries. So this is the first query, this is the second query. query number 3, query number 4. Basically, all queries have the same structure. I'm working with the relation integers. So all 4 queries state or look at, in the from clause, at the integers relation. And all 4 queries select this expression here, I times I, so I'm building the square of what is inside an element in the relation. So this is the common part of these 4 queries, the I squared, and consideration of the integers relation. What makes these 4 queries different is the use of distinct and the use of order by here. Let's look at the result. So I emphasize again, our starting relation is a relation where no duplicates are present. In the relation we have -2, 0 and 2. And now let us look at the first result. I'm squaring here the I, so I'm squaring, I go back again, I'm squaring the -2, I'm squaring the 0, and I'm squaring the 2, and this results in 4, 0, 4. So starting from a set and doing some computation here in the select clause, and this is possible, as you see, in the select clause, ends up here in a result which has duplicates. So starting from a set and doing some interesting things with the elements in the set, it may be the case then when you grab 2 different elements from the set, doing something to the element of the set may result in the same value as it is done as it happens here with the -2. -2 times -2 is 4, and 2 times 2 is also equals 4. So starting from a set, it may be the case that you end up here in a collection which has duplicates, and the technical term in UML and OCL for this is the bag. As you see here, this is in SQL, this is the most simple form that a query may be formulated. The query is formulated here with the select and the from, and I'm squaring here the result, and I have used not the distinct, and I've not used here the order by. So you may think that this is the canonical way that SQL presents a result. So the canonical way, when you state a simple select from or select from where query, the canonical result retains duplicates. Only when you want to eliminate the duplicates, as in this second query here, I have inserted the distinct, only when you are doing something explicitly here, you are eliminating the result. So using the distinct here leads to the elimination of 1, 4 here, and you get the result 0 and 4. And roughly this corresponds to a UML-OCL set. The canonical form corresponded to a bag, to a UML-OCL bag. So, not using distinct, using order by, not using order by. And now I'm playing around in SQL these are SQL games that I'm playing here. And now I'm playing around with the order by, and I take first the first query that we have used, and I'm ordering here by the first element, and I want to see the elements in descending order. And instead of showing this result, the query starts with presenting 4 2 times and the 0 the third as a third element in the result. And this roughly corresponds to allowing duplicates in the result, but building a sequence, giving an order to the elements in form of a sequence here. And the last option is to use distinct and to use order by, and then we will end up not in the result 0, 4, but in this case we will end up in the result 4, 0. So we have 1, 2, 3, 4 different results stated that come from these 4 different queries. And this is something that is happening and going on in SQL. So some of the typing options that are available in UML and OCL and so on, these options, they are available in SQL, but they are not explicitly available as typing options, but they are implicitly available through the use of particular keywords in the query or not. So we have roughly seen these 4 different OCL collection kinds. The 4 different collection kinds in UML and OCL are the set, the bag, the sequence, and the ordered set. The set, in the set there is no particular order on the element, and a set contains an element only once. A bag does not have a particular order on the element, but an element can occur more than once in a bag. A sequence has an order for the element, and in the sequence an element can occur twice, as we see here. And in an ordered set, an element can occur only once, but the elements are ordered. So for example, in SQL, if we would change here the descending to ascending, we would get the reverse order here. So this is one of the main messages and one of the main reasons I've been going into some details of SQL. There is a close relationship between the options that you have in an SQL query and the collection kinds that are available in UML and OCL. And what is sort of implicit here in SQL, in the query part, these options are made explicit in UML and OCL through what I call collection kinds, through these 4 things. And again, what is implicit here in SQL is made explicit in UML and OCL, and it is available here explicitly on the typing level.